Hello and welcome to today's webinar on micromobility and two-wheeler design challenges. How to stand out in a competitive market. My name is Karin and I will be moderating the webinar in this session. Before we begin the presentation, I'd like to go over some housekeeping points. This webinar is being recorded and will be sent to you automatically after the webinar ends. If you look into the handout section on the webinar control panel now, you will find the presentation in PDF form. Of course, we would love to hear from you. Write any comments or questions in the webinar control panel, and we will do our best to get back to you. In today's session, we'll be covering wireless connectivity technologies for IoT on two wheels, how to efficiently locate your e-mobility vehicle, Cowboy bikes, gear shifted to IoT and innovation, the right type of IoT connectivity for micromobility, and then we end up with u-blox hardware and service building blocks for micromobility. For those of you just joining us, welcome to the webinar Micromobility and Two-Wheeler Design Challenges, How to Stand Out in a Competitive Market. And now I would like to introduce today's presenters. Diego Grassi has over 24 years of semiconductor experience and is a senior manager in application marketing at u-blox. Matthias Vetter is a product manager, expert in RF and GNSS, and is a specialist in UDR and meter level positioning technology at u-blox. Last but definitely not least, I'm happy to introduce Simon Smolders from Cowboy Bikes. He has 7 years of experience in the electronics industry and is a senior product engineer. Without further ado, I hand over the word to Diego.
Okay, thank you, Karen. Good morning and good afternoon to all of you online. In today's webinar, we'll be covering the space of the connected two-wheelers and micromobility. So to contextualize our discussion, let's start with some definition. So if we take the two-wheelers traditional market that includes privately owned motorcycles, scooter, and mopeds, we're talking about an established industry that is projected to grow to a size of 62 million units per year by 2025. So it's a large market where we see a significant trend towards electrification and the surge of new use cases enabled by the adoption of various forms of wireless connectivity. As a subset of the two-wheelers domain, we have private and shared micromobility. And to date, private micromobility consists mostly in privately owned electric bikes, which is another large and established market with a size that has reached already 3 million units per year only in Europe. Then we have shared micromobility, which is the first and the last mile. So all the electric scooters and bikes, rentals essentially. So essentially it's a urban and most recent phenomenon that has been growing exponentially on a global scale in the last 2 or 3 years. So we have a growing diversity of electric vehicles that fulfill many user needs and use cases. But what do e-scooters, e-bikes, e-mopeds, and e-motorcycle all have in common? Well, they are all light vehicles, they are electric, and are all IoT devices on two wheels. So these vehicles typically feature a satellite-based position receiver, a cellular modem to enable cloud connectivity, and a short-range Bluetooth or Wi-Fi link for local connectivity. Now, since in today's webinar, we are touching a pretty large number of topics, and you might have different interests, I like to remind you that if you can stay connected until the end, you will get design guidelines related to the four core technology domains you see here. So we're going to talk about cellular, short range and positioning technology, and we will also talk about the importance of selecting an optimal form of mobile connectivity to help you deploy micromobility fleets globally in the most efficient, most secure and cost optimized way. So our first section is about wireless connectivity technology used for your IoT on two wheels. And we start with a look at how Bluetooth and Wi-Fi connectivity enable communication for local tasks. Now, for sake of simplicity, we have categorized use cases into groups. So we call them mainstream use cases and emerging use cases. Here you see a non-exhaustive list of Bluetooth use cases. Essentially, Bluetooth low energy is used to wirelessly unlock or lock vehicles with a smartphone. So essentially what is called keyless access to a vehicle. Using BLE connection to your phone, you can activate rental services with over-the-air keys management, and you can configure a rider preferred settings. With a Bluetooth Classic link connected to a user's mobile phone, you can give access to infotainment and multimedia or other forms of internet access to a vehicle. And if you have a more high-end type of two-wheelers, typically equipped with more complex type of HMI, you can use host-based type of BLE modules to enable safe communication, for instance, through a smart helmet. Here we are showing, for example, a nice implementation with multiple peripheral connectivity and simultaneous audio streaming, for example, with streaming reaching both a rider and a pillion. And we should also mention that considering the adoption of Bluetooth 5.2, there's a possibility to open up to new use cases with the support of audio over the low energy channel and with enhanced data rates. Now, some of the main problems that developers experience when using older generation of BLE modules are typically related to security. So we advise when you are selecting BLE modules to use modules that support secure boot, secure BLE connection, and secure simple pairing. Two major other challenges faced typically by designers when using BLE are a too short range and a too low speed. And we see here that by using modules supporting BLE 5.0, the 5.0 variant of the specification, you might be in a position to solve these problems. In fact, BLE 5.0 brings groundbreaking enhancement in three areas, essentially. So you will have an extended range. So there are actually new modulation options that have been introduced to extend the range up to 4-fold with the same output power. So this means that in line of sight, the range of Bluetooth signals is expected to exceed 1 kilometer range using the same amount of power. A second enhancement is the increased data rate. So the spec doubles the amount of data that can be transmitted per second, which also means that with the same amount of data transmission times, you can cut the power consumption by almost 50%. And the third enhancement is related to extended advertising capability. Here you can extend by 8 times this capability. So Wi-Fi and BLE links can also be used to configure the vehicle from user or for service and repair operation by the crew of rental services. Typical use cases here are a photo, so firmware update over the air, or you can download, you can have log data transfer over Wi-Fi during typically nightly charging, or technician can use BLE and Wi-Fi to configure and read out data from the vehicle in the field. So still in this area, there are quite interesting new use cases that might require also larger type of throughputs. For instance, in sports performance analytics, the offloading of vehicle data can be particularly demanding. So this typically happens because you need to transfer large files that include CAN bus data with a lot of information from the vehicle engine, from sensor, and typically also GNSS data that was stored using a very high sampling rate. So in this specific scenario, this is the specific scenarios where modules supporting Wi-Fi 6 can be very helpful. In fact, Wi-Fi 6 is the latest wireless LAN standard, so it's called 802.11ax, and it has been introduced to bring some enhancement in the area of density, battery life, and speed. So, and we say here, the throughput is relevant for this specific use case. So the data rate, so with wider multiple simultaneous channels, the data rate when using Wi-Fi 6 modules can reach up to 3.5 gigabit per second. Let's see now some emerging use cases. We are showing here an interesting case where where you can use Wi-Fi for localization of vehicles. Wi-Fi, in fact, can be used to get a short time to fix for GNSS, or as a fallback when GNSS, for some reason, cannot get a fix. So typically when e-scooter or e-bikes are stored in areas with no GNSS signal coverage, for instance, in parking lots. Now, in this case, you will need a Wi-Fi network infrastructure so that the vehicle can scan for nearby Wi-Fi access point, and the scan result represents a fingerprint of the current position with information about the signal strength, so the signal strength that is coming from the different access point. Now, by sending this specific fingerprint to a location server, a calculation position can be returned. In this type of implementation, we should say that the accuracy clearly depends on the availability of access point and on their geometry. BLE can also be used for sending periodic Bluetooth advertising messages, so also known as beacons. And it might be possible to use these beacons to detect, for example, a specific bike in a parking area. Here, essentially, similarly to Wi-Fi, we use a smartphone and a Bluetooth receiver embedded in your vehicle to estimate the position based on the signal strength. This is relatively simple and low cost, and it requires low current consumption, but this solution generally provides a rather coarse type of accuracy. And we have here two places two way to improve accuracy. One is by using several fixed receiver, and this clearly depends on the available infrastructure. And a second method is today possible thanks to the new feature of direction finding that has been introduced in the most recent variant of the BLE specification. Direction finding, as you see, is in fact the main new feature introduced in the Bluetooth 5.0 core specification, and is based around the two concepts of angle of arrival and angle of departure. By using the feature of direction finding, a Bluetooth receiver can, in addition to the signal strength, also determine the direction from where the signal is being transmitted. And if you use for instance, the angle of arrival method in combination with a signal strength, you may improve accuracy down to the centimeter level. At u-blox, we have one of the largest portfolio of short-range communication modules, and here you see just a subset of our portfolio. We are listing essentially products that are suitable to address the two-wheelers domain. We offer Wi-Fi, Bluetooth, and V2X solution available in the forms of modules and chipset. We have multi-radio module supporting Bluetooth and Wi-Fi, standalone and host-based Wi-Fi module supporting 2.4 and 5 GHz, and we are developing also 802.11ax modules, so Wi-Fi 6 that will be available soon. As far as Bluetooth, we are supporting BLE 5.0, so including long range, BLE 5.1, including direction finding, and for audio, Bluetooth Classic with both basic rate and NAS data rate. In addition to modules, we have a system in package with very small form factor. We have one example here. It's, for instance, our ENA B1 that comes in a 6x6mm size. So essentially a form factor that can be very useful, for instance, when you need to have an efficient component integration to fit your IoT communication board in a small vehicles such as an e-bike or on a scooter. Now let's move to cellular. So cellular connectivity. So cellular modules are used in e-mobility vehicles to communicate with backend infrastructure to enable a large number of services such as vehicle and user activity tracking and anti-theft system. As a matter of fact, all rental sharing business is indeed possible only because cellular modules enable fleet monitoring, essentially giving the possibility to remotely locate the vehicles, book the vehicles for a ride, and enable the processing of a billing after the trips. Cellular is also used for several forms of vehicle remote diagnostics, for example, monitoring the battery management system, the condition of the engines, or for other type of preventive maintenance and real-time support. Crash detection notification and emergency call are also possible thanks to the cellular modules and embedded in your e-scooter and e-bikes. And eventually, cellular modules are also the building blocks for other added value services such as usage-based insurance scheme, or we can think that by combining Cellular with high precision GNSS, it is possible to implement sometimes of very high accurate tracking, and we know how much geolocation data is becoming more and more important and essential for creating a lot of social advertising strategy and market campaign. Now, we see that cellular is key. We have had this example that showed the evidence of the importance of cellular, but what is the most appropriate form of cellular technology for micromobility, for the micromobility industry? As you see here, this cellular technology is growing in complexity, introducing different specifications while moving towards 5G. In the upper part of this graph, we have LTE categories launched to address the broadband type of use cases, typically requiring high bandwidth and low latency. While if you focus on the lower part of the graph, you see new categories such as LTE Cat1, LTE Cat-M, and narrowband IoT. Now, if the first generation of the connected two-wheeler still use legacy 2G and 3G connectivity, we see that LTE Cat1 and LTE Cat-M are considered today the optimal choice for all new future-proof designs. In particular, LTE-M is generally the best technology option for the so-called mainstream micromobility platform. This is because LTE-M is a technology developed to address the need of high connection density, energy efficiency, extended coverage, low device complexity, and with low device complexity, we have enabled also lower cost. So how all these attributes bring benefit to our micromobility design? The LTE-M specification is optimized for data throughput in the range of 100 kilobyte to 200 kilobyte range. So essentially the typical throughput necessary for the standard type of monitor and tracking of use cases in micromobility vehicles. Then LTE-M optimizes energy consumption and therefore help to increase the life of the battery of vehicles, or it can help to reduce the size of the battery of the vehicle, which is quite another interesting design aspect. LTE-M and also narrowband IoT allow to increase the number of vehicles that can be connected simultaneously to one node of the cellular network. This can be notably important for when we think about large fleets of vehicles that are being deployed in urban scenarios, and when we think that these large fleets need to coexist with an increasing number of other connected IoT devices. And eventually, LTE-M is a technology that brings enhanced radio coverage of better radio propagation. So what does this mean? So in urban scenarios where e-bikes and scooters are mostly used, this means the possibility to reach vehicles that can be, for instance, obscured by trees or street furniture, or can be stored in parking lots or in other indoor location, or even when bikes have been stolen and are hidden in a shielded area. Now, if we go to the design guidelines, one aspect that you should consider when you are selecting LTE-M type of cellular module, so you should consider that to select module that support a 23 dBm transmit power. So this choice will result in no output power limitation. So you will be in a position to guarantee that your device will operate in all signal conditions. So essentially, no problems at the cell edges, no coverage issues in weak signals, no unwanted retransmission. Now, some manufacturers in the market, in order to reduce costs, support only 20 dBm class power. And this can eventually generate quite substantial problems. For example, what happens if we work at 20 dBm in weak signal condition? You will experience coverage issues that eventually will require frequent retransmission and increase your transmit time, and overall increase the system power consumption. Another problem when using still 20 dBm is that the antenna efficiency becomes much more relevant. So This means you will face higher complexity in your design. And since we know that IoT boxes embedded in e-bikes and scooters are very often integrated in vehicles, in area of vehicle that makes it particularly challenging to design antenna, then 20 dBm will generate some issues. The use of modules, so-called combo modules, so basically modules that integrate, so multi-chip modules that integrate a cellular modem and a GNSS receiver, is a common practice for several IoT trackers. This choice clearly helps you to optimize your PCB design, particularly when you have limited space to fit your communication box in the vehicle. And in this case, when you decide to go for combo modules, we advise you to select components that include a dedicated antenna interface. In fact, only this architecture will allow your application to run simultaneous LTE and GNSS. And with this design option, you can obtain a superior GNSS performance in terms of sensitivity, accuracy, and time to first fix. Independent LTE and GNSS antenna gives you also maximum flexibility to use GNSS whenever you want to use, no time sharing between GNSS and LTE. You will have a GNSS engine that can also run when the LTE radio is off, so to preserve power or it's in power save mode. Conversely, when you are using a time sharing approach, you will risk to lose LTE paging, some paging events, and this can affect your application capability to get, for instance, some important information from the network. Or you will risk network disconnection and eventually waste power to resume LTE connectivity. Now, here we present a selection of still u-blox cellular of modules, in this case cellular. We are showing LTM, Cat1, and Cat4 modules that are used in main two-wheelers platform. Today, our business partners are mostly in the micromobility space, are mostly using LTM technology. And in this area, so in LPWA, u-blox has been a market leader in the introduction of LTM. We have actually been within the first supplier globally to get LTM modules certified by American operators. And actually, since a couple of years, it's more than a couple of years, we have scaled up in volumes with our first generation of SAR4, which is an LTM product family. We are actually now launching the second generation of SAR4, supporting also narrowband and 2G fallback. And we have launched this year our R5 platform, which is a family of modules based on a cellular chipset designed completely by u-blox. In particular, with these platforms, thanks to the design, the fact that it's based on our own chipset, so thanks to our core IP ownership of the LTE modem, the security blocks, the power management, and also the GNSS technology, we are bringing to the market a set of unique features. Security is one area where u-blox has been invested substantially since year. And this is quite relevant for the discussion today because the micromobility industry is still certainly subject to several security threats. You should consider that both ride-sharing services infrastructure and micromobility vehicles are in fact subject to malicious attacks. For instance, you can have unauthorized remote control of a vehicle that can certainly generate a big safety problem, or you can experience denial of service events that can disrupt booking and billing system of micromobility operators. Now, to solve this problem, in our Cellular R5 product family, we have included an embedded secure element, so essentially a crypto engine. That is one of the building blocks of u-blox root of trust. So our root of trust is a robust security framework that is the foundation of all u-blox security services. So essentially, with R5, we can provide a rich set of security service features that could be useful to support the micromobility partners to deploy a global platform with a level of security that is necessary generally to preserve data privacy, confidentiality, and eventually also the safety of micromobility users. Another aspect that's like more a premiere today is like essentially R5 is a product family is available in module, LGA modules, but it will be soon available also in a small system in package. So we are in fact launching in a few weeks a fully encapsulated 15 by 50 millimeter system in package, still based on LTM chipset from u-blox. And such a small size product that will include also a GNSS engine is a good candidate to support the next generation of e-bikes and e-scooter platform. Okay, now we have our first poll. I pass the microphone to Karin.
Hello, everyone. Let's check your engagement and ask you a couple of questions. So I'm going to launch the first question. Please answer the question on your screen. What do you anticipate your yearly sales to be for your micromobility vehicle? 1,000, 1 to 20,000, excuse me, 20 to 100,000, over 100,000, or I do not directly sell micromobility vehicles. I see the answers are coming in. Let me give some others some time to also answer. Thank you. Okay, closing off now. And the results show 70% say they do not directly sell micromobility vehicles. That's very interesting. 11% say 1 to 20,000 per year, and 66% 1K per year, 8% 20 to 100K. All right, now let's do the next question. One more question. What wireless connectivity technology are you considering to use in your micromobility design? Bluetooth Classic and or Bluetooth Low Energy, Wi-Fi, LTE M NB IoT, LTE Category 1 or above, and lastly V2X. Please pick your answer. Yes, I see the answers coming in. Thank you. All right, I'm going to close it off now. And the poll results show that 74% are doing LTE-M and NB-IoT, 61% Bluetooth Classic and or Bluetooth Low Energy. Very interesting results. Thank you very much. And now I hand the word over to Matthias.
Hello everybody, I hope you can hear me well. I'd like to share with you the positioning stuff. So getting right positioning data is very important for micromobility. So let's start looking at the use cases. First of all, and the most important probably, is the user. The user wants to find the device. That's very simple. Is it that simple? What is the user looking for? Is it 5 meters accuracy, 10-meter accuracy? I don't think that matters, but what the user wants is that the accuracy is very reliable. So if it's 10 meters, he doesn't want once in a while to get 30-meter accuracy. So reliability is very key also to differentiate from competitors. So that's to keep in mind for the user. Then looking at the operator is looking to do maintenance, battery replacing, fleet balancing, maybe also recovery of stolen devices. In the end, it's also finding the device. So the use cases are pretty similar, and the accuracy probably that is needed is in the same range, 5 to 10 meters. So ultimately, what the operator wants to do and why he wants to find the devices quickly is to reduce operational costs. If you waste time looking for the device, that's just a no-go. And then looking at an emerging use case with city authorities, they start banning the devices because they're just lying everywhere. Maybe also in some area of the city, they don't want such electric devices. So there are some areas that are banned, and also it's not allowed to drive on sidewalks in many cities. So how can the position accuracy help? Well, if the operator knows that the accuracy of the device is very good, it's quite easily possible to enforce such regulations. And with that, by design, you can show also to the city authorities you're capable of doing so. And with that, you're likely the preferred operator. And if there's only one or two being selected, this enhances your chance of being selected. So let's look at some technology for positioning. Start on the left, standard precision. That's GPS as we all know. The receiver calculates position based on satellites. The satellites, there are 4 satellites here representing 4 constellations. So we have GPS, but as well we have Galileo, we have GLONASS, we have Beidou. And the most recent receivers can make use of all of these constellations in parallel. And with that, the precision has been improving over the past years. The drawback of this solution is that signals from satellites, when you go into cities, they get reflected on buildings. And with these reflected signals, the accuracy can deteriorate. And with that, the position, it's not that good, it's not that reliable, and that's why we move on the ladder, go to untethered dead reckoning. What is that? Basically, we just add a sensor. This is an independent source of information, and the sensor is typically a 3D sensor, 3D accelerometer, 3D gyroscope that helps to improve the position. As the receiver knows that the signals get worse, he can put more weight on the sensor and with that stabilize the performance. Going to the next one, so-called automotive dead reckoning, we're adding the wheel tick. What's wheel tick? That's speed information, and that you get from the device. So it's not really limited to automotive. The name is quite silly in this context, but it's just how it has been named for many years. Then going another step further, going to high precision GNSS, and still with dead reckoning, so still sensors and wheel tick. The idea here is to get correction data from either through the internet or through the satellite to get over the problems with atmospheric changes. And at once, we can also introduce dual bands here, so using L1 and L5 bands to further improve the accuracy. Here enabling decimeter level in the cities. There are other alternatives, maybe obvious ones, which we think are not really optimized for micromobility needs. Diego already mentioned the combos, so using GNSS from cellular modems with shared front ends, but ultimately it gets down to one bullet point when using these solutions. It's insufficient accuracy. Even for the basic use case of finding a device for the user, you might get okay accuracy if you're in the open sky environment, but as soon as you enter cities, it's not accurate enough. And that's what customers also tell us. Since it's the obvious solution, the cheapest solution, customers try to use it, but very soon they recognize that it's not good. It's also increasing their operational costs, so they get away from it. Another option is dual band. Dual bands basically solves the same problem as dead reckoning, so it's improving the urban accuracy, but it's also adding costs. So the RF part of it, the antenna, the SAW filter need to be more wideband, and with that they get more expensive. So once in a while it could be the same accuracy, but what is definitely the case, it's getting worse with bad signals. when the signal levels drop or disappear completely, you're still relying on the satellites, on the same satellites. And having a sensor is an independent source of information, which is why we think using dead reckoning products is a better choice. So let's look at some examples now. That's Frankfurt downtown. So very difficult conditions, very tall buildings. And what we see on the right is the u-blox M8 technology, so relying on 3 constellations. And here we see that the position can go off by multiple dozens of meters. So in such an environment would not be the right solution for a micromobility product. Now, if we just add sensor, gyroscope, accelerometer, we see we don't get a perfect solution, but it's much more accurate than using satellites only. Then let's compare if you go to a parking garage with the open roof. So there is a roof, but on the side is open, so you're still able to get some satellite data once in a while. And with GNSS only, you're obviously off by far. Now, if you go to UDR, we see at least the position is within the building, so that's quite good. It's not exactly following the track, but it's still quite good, I would say. But then with ADR, with the wheel tick, you can especially recognize slow speeds, and that's helping a lot to get accurate positioning. Still in meter level, but that's good enough in many use cases. So dead reckoning, talking about dead reckoning quite a lot, and I think that's really the message of this webinar, to give you a motivation to try it. And I would recommend to go step by step. If you start in a car, it's as a GNSS only product. You plug it and it starts, so it will automatically align itself, it will know how it's aligned, and it will calibrate. And after a while, you will get into the so-called sensor fusion modes and get the benefits of the sensor when you drive into cities. Then the next step, when testing UDR on a two-wheeler, here it requires some manual setup. So the device will not be capable to know its alignment because the two-wheeler can roll, and with that has a higher degree of freedom than a car. So you need some configuration message to tell the receiver how it's aligned within the vehicle frame. So we have some documentation about this that gives you help to do it. And then here again, calibration is automatic. Then if you want to go to ADR, you need to connect the wheel tick, which is different with every device, but many customers have done this. We might also help if needed. So what is this calibration all about? Well, the sensors need to calibrate themselves. That's just the behavior of these kind of sensors. And they do that with the satellites. So, and to get good calibration, you also need good satellite view, good sky view, and good position accuracy ultimately. And at once, you also need good dynamics. So ideally figure of 8, but 90-degree turns are good enough, and you need minimum speed of 18 kilometers an hour. The picture is at Zurich Airport. I took a public bus and turned on this UDR product, and you see that just after a few turns and a few meters of driving, the receiver will calibrate. That's a brown area where it enters sensor fusion. So it's all automatic and it continuously optimizes afterwards. So that's an overview of the different products, what you get. And as you see, the Open Sky figures, the data sheet values, they don't really help to compare the products. So it's really improving the value in urban environment. And the message to remember here, compared to GNSS only, it's a factor of 3 to 4 improvement. Obviously, it depends on the city. One city is going to have higher values, but low or lower, but there is a significant factor of improvement. I'm not going into all details. We have limited time today, but I think that's, if there's something you should remember, then that's it. This slide is just to give you an overview of the different products, so to find them more easily with our cryptic naming convention. It's maybe good for us, but quite difficult for you. So this is some help to locate the right product and then to look at the data sheets and get some more information online from our webpage. So what's next? u-blox M9, I mentioned already, is capable of receiving 4 constellations at once, so 4 GNSS constellations at once, and we see that on the picture on the right. Green is the truth. The light blue is u-blox M8, so using up to 3 GNSS, and the purple one is u-blox M9, already significantly improving the performance. And now on top of that, we will introduce some UDR and ADR products based on this platform that further helps with urban position accuracy. On top, we'll have some more features like wake on motion to detect motion, as well as some security features, so spoofing detection, for example, also SNMA, Galileo Open Service navigation message authentication. And on top also we'll use 100 Hz IMU data, which you can reuse as well for your application. So we share that with the host, and you can do driver behavior analysis or stuff like this. So let's conclude. So we saw their standard precision GNSS with dead reckoning, and it provides improved urban accuracy at meter level. And this is basically solving today's main challenges, finding the devices easily, ultimately increasing customer satisfaction and reducing operational costs. And then to go to the next step, going to high precision GNSS, still with dead reckoning, going down to decimeter level. This is really enabling new use cases. That's for the future, or even might someone to start now with this, to detect rides on sidewalk and banned areas to fulfill the city regulations. And also on the picture, we see these spots for the e-scooter pretty small. So if you wanted to detect if the devices are left correctly, you need decimeter level accuracy. And just to remember, yeah, this is by design because you really know what is going on with positioning. Want to spend maybe a word about it, about dead reckoning and u-blox. So u-blox has been working with dead reckoning for quite some time, especially in the automotive sector. Some automotive customers do their own dead reckoning, but they come back to us even now because it's quite some effort to do that. And with two-wheelers, we started 2 years ago, so the initial solution might have been the initial solution, and we since then improved, and we will further spend more money in this field because that is definitely some very good business for us and also for the operators. So thanks a lot. Handing over to Karin for the poll.
Thanks, Matthias, for giving that overview on positioning solutions. Now going on to the next poll round. I saw that there were some audio issues. Let us know if it's better now. Okay, so first question up. What type of accuracy do you need to locate and track your micromobility vehicle? Less than 50 meters, less than 5 meters, or less than 50 centimeters? I see some answers coming in, giving some time for the others to answer. Okay, closing it right now. Thank you, everyone. Great results. Very interesting. So the most say less than 5 meters, and then 36% say less than 50 centimeters. Thank you very much. The next poll. What type of positioning technology are you considering to use in your micromobility design? Single band GNSS, dual band GNSS, combo solutions, cellular plus GNSS, sensor enhanced GNSS with ADR or UDR, or high precision GNSS? Let's see. I see the answers coming in. Thank you for answering the questions. All right, closing it. And here are the poll results. So the most, with 56%, say sensor enhanced GNSS with ADR or UDR. And then 40% combo solution cellular plus GNSS. Thank you very much for those interesting answers. And now I will hand the word over to Cowboy Bikes, Seaman.
Hi, everyone.
Hi,
My
Seaman,
name
we
is,
hear you.
yes, if we can go to the slides, there we go. So hi, everyone, my name is Simon Smolders, and I'll be talking for the next 6 minutes or so about how we use connectivity at Cowboy. Personally, I've been involved at Cowboy as a product engineer in both the hardware and software domains pretty much since its conception in 2017. So first off, for those of you who are not familiar with Cowboy, we are a company that designs, manufactures, and sells direct to consumer the bike you see in the slide here in the upper right corner. Many people don't notice it immediately, but it's an electric bike. The motor's in the rear wheel. It's a very sleek looking bike that comes with a detachable battery and has lots of tech inside. Importantly to note is that we use the smartphone as the display over a BLE connection interface, and during riding, your smartphone becomes an almost natural extension to the bike. That way, we also, of course, harness the power of your smartphone's connectivity options. We've grown at a very rapid rate, at a rapid pace, as you can see here, during the past 3 to 4 years. We started in early 2017, observing a great opportunity to transform the e-bike from a boring and uninspiring product, mostly used by an elder community, to a product for people that are in love with great design and powerful tech. So the type of target market that buys Apple products or a Tesla, if you've got enough money for that. You can see a few simplified numbers about our growth on this slide. I think it serves as a great confirmation that using the right IoT and the right application is something that the mainstream customers are really getting excited about. It's not just early adopters, but it's definitely also going mainstream. Also crucial to that growth, I think, has been our strategy in changing the rules of the game of the bicycle industry, which is really quite antiquated in this day and age and has lots of middlemen, distributors, bike shops, etc., which we happily bypass going direct to consumer. And importantly, we're building a connected product in line with that direct to consumer approach. I've already touched on, I think, our main value proposition being the sleek design, great ride feel, and powerful tech, all at an affordable cost. We sell it for about 2,300 euros. But importantly, we also strongly focus on owning the core IP of this value proposition through vertical integration. So most importantly, especially to me as a designer, we design our own communications module, which both the hardware and software parts of it. And that makes this bike into a connected product, giving the ability for it to be tracked, remotely diagnosed, etc. Next slide, please. If possible, if we could get the next slide up on screen, thank you very much. So here's a nice little slide with a few important keywords describing the bike best. Since it's a webinar about connectivity solutions and micromobility, I'll focus on that aspect here. So we're using a trio of connectivity solutions from the u-blox portfolio, as you can see here. We're using the Nina B3 series for BLE. We're using for positioning the SAM M8, and finally for cellular, we want both 2G for Europe as well as LTE-M for being future-proof. So we're using the Sarah R4 for the cellular connectivity. And we're leveraging these connectivity capabilities basically for 3 main topics. First of all, we're addressing this fear of getting your bike stolen. Secondly, we're ensuring amazing customer service. And thirdly, we're using software updates. So first off, we're addressing this, this fear of getting your bike stolen. We have an accurate tracker to locate your bike using all 3 technologies. So the positioning, cellular, as well as BLE, if you're in the last, let's say, 30 meters. To see sort of where it is, and you can get closer based on the signal strength of that BLE. And on top of that, we sell insurance directly through the app at the click of a button. Secondly, we use connectivity to ensure the highest level of customer service. So what do I mean by that? our customer support team is reachable directly through the app, and they can get live access to your diagnostics data on your bike. So it basically appears that they're right there next to you solving your problems, and you don't have to go anywhere on your Saturday or Sunday afternoon. You can just stay where you are and get help digitally. Thirdly, having the capability to perform software updates really means that your bike will become more powerful over time after you've purchased it. For example, we have upcoming automatic unlock, so you'll never have to take your phone out of your pocket. Proximity-based BLE, it unlocks for you as you get close. And finally, we also have upcoming a crash alert release, which basically sends a message containing your position once you crash to your emergency contact if you allow it. So getting back to connectivity and micromobility, I think these three examples show us that connectivity to us isn't just this nice little add-on to our product. It's really a central pillar to Cowboy's offering and a sort of raison d'être, as we say, a reason for us to exist. Next slide, please. So here I just added a little slide about how incredibly positive the Cowboy bike has been received by both the public at large as well as these prestigious press outlets. We've got Tech Radar, we've got The Verge, we've got The Guardian, so we have a lot of positive reviews. And people are really raving about the design, the ride feel, but also definitely this connectivity aspect, especially the Find My Bike tracking, software updates, and the on-demand service. Next slide, please. And finally, since this is a webinar from u-blox, I'd like to just talk a few words about our fruitful collaboration between Cowboy and u-blox. So first off, when you're moving at the fast pace as an innovative and well-funded VC-funded startup in the IoT space, it's really instrumental to have support, but also really short and reliable lead times. And u-blox has really helped us a lot during development, certification, and production. Another advantage is that having a vendor that is a one-stop shop for connectivity is a big pro, as many modules have synergies, especially the cellular and positioning have many synergies between them. And finally, I also want to point out that, like every good cook knows, you need to start with great ingredients if you want a great dish. We really don't have the time to iterate continuously and improve things, so we really want to have good components to start off with. So buying great quality at fair price is something that's central to our own product offering, and so we're clearly aligned with u-blox on that. That's it for my time. Thanks for listening, and I'd give the word back to Karin.
That's me, that's Diego. So thank you very much, Simon, for your contribution. Great introduction to Cowboy bikes. Actually, at u-blox, we are really proud to be part of these fantastic vehicles. So let's move now. There's a problem flipping the slide here. Okay, let's move now to the last part of this webinar. With the final section, we have a look at the right type of IoT connectivity for micromobility platforms. Now, when you are deploying IoT projects on networks that need to scale, the cost certainly is a significant factor. As the number of devices increases, so does the overall cost of operation, the operation. So this is down to many factors, including not only the cost of the hardware itself, but also the cost of the data transmission, power supply, essentially, as well as cost of unreliable data. So you see here, essentially, the complexity is growing. The issue of cost predictability is further compounded by the growing complexity and fragmentation of the IoT ecosystem. Whatever the application, generally there are many types of ways to gather data from and push instruction to the device. And each method brings with it different challenges and subsequently different forms. Now at u-blox, we have developed a platform to try to help you to solve these problems. So we have a connectivity platform that we have designed using a messaging standard that was specifically developed to produce small messages. We provide a comprehensive end-to-end connectivity solution based on the industry standard MQTT SN, which is a variant of MQTT. This variant has been designed specifically to address sensor networks with a scale in mind. So MQTT, you might probably know, is already a lightweight machine-to-machine messaging protocol, which has, for instance, up to 90% more efficiency than HTTP. because essentially it doesn't require a TCP/IP stack, and so it is ideal for large-scale networks, particularly where networks lack in bandwidth. Now, u-blox connectivity platform use a carrier-grade MQTT broker working on a publish and subscribe basis, and exploits, as we said, MQTT SN variant of the spec. So it brings more efficiency in both the transmission, the data transmission, and power consumption. So how this is obtained? Essentially, this is obtained reducing the overhead size of the data packets in transit, and this gives improvement in cost and also in battery longevity. To give you, let me give you an example just to contextualize. So the typical TCP/IP overhead for a track and trace application is in the range of 30 kilobyte, and if you use this overhead, if you use a u-blox platform, can go down to 50 byte with the implementation based on MQTT SN. Now, u-blox connectivity helps you to reduce the cost of ownership, essentially bringing benefits in terms of predictability of cost with on-demand scalability, and by giving you a true global connectivity with an MQTT network that can operate in 190 countries. This is done having network partners, so having basically partnership with up to 640 mobile network operator partners. Now, in today's fragmented cellular technology landscape, having a form of connectivity with a broad geographical market reach is essential. So, in fact, most of shared micromobility operators are typically seeking to grow beyond one single market or one single country. So the need to ensure the connectivity solutions, to have connectivity solutions that are using certifying operation on cellular network in different markets is key. So another aspect is that this portability throughout different geographies is also relevant for private owners, for the user of the bikes, of the scooter, that increasingly they expect to have hassle-free travel across borders or even across continents. So through our platform, we offer a seamless portability, and we also offer a seamless integration into the most common or the leading cloud platforms such as AWS, Microsoft Azure IoT Hub, or IBM Watson IoT, also Bosch IoT. We move now to the third and last poll of this webinar.
Thanks, Diego. So we're keeping you engaged here. Last poll. What is the average payload size on your sent by your vehicle? Less than 500 bytes, 500 bytes to 1 kilobyte, more than 1 kilobyte. I see the answers coming in. Thank you. Waiting a few seconds for the others to answer. All right, closing the poll right now. The results show that the most have less than 500 bytes, then 500 bytes to 1 kilobyte, and then more than 1 kilobyte. Thank you. Next poll, and the last one. How frequently is the payload sent? Once per day, once per hour, every 15 minutes, every minute, or more frequently? Please answer the question on your screen. Yes, I see the answers coming in. All right, closing the poll right now and sharing the results. So the most say every 15 minutes, but it's quite tight, to 25% saying more frequently, and then 23% once per hour. Thank you for those answers. And we move on with Diego to share some closing words this session.
Thank you very much, Karin. So to conclude this webinar, so we give a brief overview of, we present some tools that you can use to get started with your micromobility design. So we have some evaluation kit with integrated antenna for our GNSS solution, supporting also sensor fusion and the reckoning. That, as Mattia highlighted, is a key technology. Our B36 blueprint is a nice reference design with coexisting GNSS cellular, GNSS cellular Bluetooth low energy, and which is available in a small form factor for possible fast integration into your IoT boxes and micromobility vehicles. And then you see also our starter kit for MQTT anywhere connectivity. So we are at the end of the webinar. So a few words about u-blox, or how we position u-blox with this industry. So with more than $500 million of GNSS chipset and more than 50 million serial modules shipped to the market, u-blox has built mainly through innovation a 20 years global leadership in automotives. So we are moving forward. We are expanding this position. We want to expand this position to the micromobility markets and to the two-wheelers that we believe are really candidates to propel an important growth in the transportation segment. So for the moment, we thank you very much for attending this webinar. We hope you have found it interesting and useful. We look forward to read and answer your question, and we look forward to talk to you soon about your micromobility projects. Thank you so much.